Good morning, children. Today we will start the new chapter, that is surface chemistry. The surface chemistry is that branch of chemistry which deals with the study of the phenomena occurring at surface or interface. Interface is the surface between the solid and liquid, or between the two substances. So the surface, a process which occur on the surface, we study here in this surface chemistry. Now we will study the phenomena first, that is called as adsorption. You already know about the absorption, and in the absorption, when you put a cotton into water, then the cotton will absorb water. So the concentration of the water in the cotton throughout same. But the adsorption is a different phenomena, and this phenomena is only related to the surface. The phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, resulting into a higher concentration of the molecules on the surface, is called adsorption. When the molecule of some substance which are there on the surface, then their concentration will be higher on the surface, but they do not diffuse into the bulk, then the concentration in the bulk is very less, and then we say this process is called as adsorption. So in the adsorption, the concentration of the molecule is high or is more at the surface and the less in the bulk. Bulk means inside the substance. So in this way, if the concentration of molecule is higher at the surface and low at the bulk, then this process is called as adsorption. Now in the adsorption, we use many terms. The terminology is there, in which we study about the adsorbate. Number one, adsorbate, you have seen here some molecules are there on the surface of the solid or liquid surface. So the molecules which are there on the surface, they are called as adsorbate, or we can say the substance which is adsorbed on the surface is called adsorbate. For example, and some carbon dioxide, in the carbon dioxide gas, if we put some charcoal particle into it, then there is decrease in the pressure of the carbon dioxide, and that is due to the adsorption of carbon dioxide on the surface of the charcoal. And then the carbon dioxide will present on the surface. So the surface, the substance, the carbon dioxide is the substance that is absorbed, is called as adsorbate, and the surface on which the adsorption occurs is called as adsorbent. So the adsorbent, the solid or the liquid surface on which adsorption occurs, is called as adsorption. So this is the terminology for the surface chemistry. Now we define the desorption. Desorption is the process in which the adsorbate is removed from the surface of the adsorbent. So it is defined as the removal of the adsorbate from the surface is called as the desorption. So now we will define the adsorption as positive and negative deviation. Now first we define the positive deviation. When the concentration of the adsorbate is more at the surface of the adsorbent than in the bulk, it is called as positive deviation. So for example, we can take, when a concentrated solution potassium chloride is shaken with bone charcoal, ions of potassium chloride are adsorbed more on the surface of the charcoal than in the bulk. This is an example of positive adsorption. Now the second is the negative adsorption. In the negative adsorption, the concentration will be more in the bulk but less in the surface. So that is the opposite to the positive deviation. So when the concentration of the adsorbate is less on the surface of the adsorbent than in bulk, it is called negative adsorption. For this we can write one example. For example, if dilute solution is shaken with bone charcoal, the ions of potassium chloride are adsorbed less on the surface of the adsorbent than in the bulk. It is an example of negative deviation. Now we can define the desorption also. The desorption, we will define the sorption. All these words are derived from sorption. So the adsorption is the process in which both adsorption and absorption occur simultaneously. In the adsorption, the concentration of the adsorbate is same as on the surface and as in the bulk. So when the absorption and adsorption occur simultaneously, then it is called as sorption. Children, now will study the factors affecting the adsorption of gases by solids. So on the surface of the solid, the gases are adsorbed to some or more extent. So here we will study the factors which will affect the adsorption of gases. The first point is the nature and surface area of adsorbent. It is found that the same gas is adsorbed to different extents by different solids at the same temperature. Further, it may be expected the greater the surface area of the adsorbent, greater is the volume of the gas adsorbed. It is for this reason that substances like charcoal and the silica gel are excellent adsorbent because they have highly porous structure and hence large surface area. So it depends upon the surface area of adsorbent. So in attention we can say larger the surface area available, more adsorption of gas will take place. So it depends upon the surface area of the adsorbent. The second point is the nature of the gas being adsorbed. Normally the different gases are adsorbed on the same adsorbent in different amount. So their volume will be different when the adsorbent is same. So the gases will be adsorbed differently. So here the gases which will be adsorbed, their volume will be different. So the nature of the gas which is used, that is related to the liquefaction of gases. Actually this point is related to the liquefaction of gases. The gases which can be easily liquefied, they will be adsorbed more. But the gases which cannot be easily liquefied, they will be adsorbed in less extent or less amount. Now third point is the temperature. Now the adsorption of the gases on solid surface decreases with increase of temperature and vice versa. So this is the property that is related to the temperature. The gases which are adsorbed on an adsorbent, then there exists an equilibrium between the adsorbent and adsorbent. So the two processes that will occur here, one is called as the adsorption and the second is called as desorption. When equilibrium is established, so there exists an equilibrium. So due to the equilibrium state, the adsorption of the gases depends upon the temperature. So this is the equilibrium, gas adsorbent plus solid adsorbent. Then the two process, one is called condensation and other is called as evaporation. Condensation is actually adsorption and evaporation is actually desorption. And then the gas adsorbed on solid surface plus release of heat. Now adsorption is a process involving equilibrium. And then you can see the forward step, that is there the release of heat. So this step is exothermic. The two opposing processes involved are condensation, that is adsorption of the gas molecules on the surface of the solid, and evaporation, that is desorption of the gas molecule from the surface of the solid into the gaseous state. So you can see this phenomena is exothermic because there is the release of heat, and that's why when we increase the temperature, when we are applying the Le-Chatelier principle here, the forward process is exothermic, and if we increase the temperature, then equilibrium will shift in the backward direction, that is in the endothermic side, and that's why the desorption will occur. So according to Le-Chatelier principle, the process is exothermic, then the process will go into the backward direction. So when there is decrease in the temperature, then more adsorption will occur. But as the temperature increases, then the gases which are adsorbed on the surface, they will be dissolved. So that can be explained on the basis of the equilibrium state. Now the fourth point is the pressure. At constant temperature, the adsorption of a gas increases with increase of pressure. So when we fix the temperature, the adsorption of the gases depends upon the pressure, because when we increase the pressure over the gas, then there is increase in the adsorption of gases. It is observed that at low temperature, the adsorption of a gas increases very rapidly as the pressure is increased from small values, because the adsorption depends upon the temperature also. So the variation of the adsorption with pressure at different constant temperature, that we will study later on, and then they are called, because these graphs are plotted at constant temperature, so they are called as the adsorption isotherms. So we'll study the adsorption isotherm in the later part. Now the fifth point is the activation of the solid adsorbent. It means increasing the adsorbing power of an adsorbent. This is usually done by increasing the surface area of the adsorption, which can be achieved in the different ways. So the adsorbing power of an adsorbent or a solid adsorbent can be increased first by increasing its surface area. The surface area can be increased by making the surface rough. When the surface of the adsorbent is rough, then there is increase in the surface area, and that's why the more adsorption will occur. So this is the one way by which we can increase the adsorption, or we can activate the solid adsorbent. The second, we can increase the adsorption by dividing into smaller pieces. So normally when we use the catalyst in the chemical reaction, we use in the powder form. So when we are converting into powder form or in small pieces, then again there is increase in the surface area of the adsorbent. So because there is increase in surface area, so there is increase in the adsorption. And and then we can also increase the adsorption of gases if some gases are already adsorbed on the adsorbent, then we can remove these gases, so there is increase in the again surface area, or more vacant space will be created, and that's why there is increase in the surface area of the adsorbent, and so there is increase in the adsorption. So these are the factors which affect the adsorption of gases on the solid surface.